and welcome to Erudite Education. We drive to seek knowledge. Now, since we have completed with the first part of integers, the next and the very important part in arithmetic of topic integers is actually the divisibility tests. So if you go through the questions that have come in the past based on the GRE exam, you will find that divisibility test is one of the most important topic that has been covered. Though the questions may not be asked directly, there are some application based questions or some really tricky questions that are asked on this particular chapter. So in this ultimate guide for GRE quantitative reasoning, we are going to cover the part 1 of divisibility tests, wherein we would be knowing and introducing ourselves to the divisibility test for the numbers from 2 to 10. And in the part 2 of this particular chapter, I will be discussing about divisibility test for numbers from 11 to 20. I suppose 1 to 20 numbers, knowing the divisibility tests of these numbers is actually enough for the GRE examination. So now we are going to start with the part 1 of this particular chapter, and we are going to look at the divisibility test for the number. Before we start anything, there's one basic concept that you need to know. How do we decide the divisibility of a number? So for any number, if I consider my number as the dividend, which is always true, if you've been given any number and you need to find out whether the number is divisible by another number or not, you need to consider that particular number as the dividend. So my dividend will always be equal to divisor into quotient plus remainder. So this is my division symbol, and suppose I am dividing 177 by 17. It makes my 177 as a dividend. Whatever is the number that is dividing my 177, that would be my divisor. So over here my divisor is 17. Whatever number I get on the division at the top, it is going to be my quotient, and whatever is remaining after the division would be my remainder. So over here 177 is my dividend, 17 is my divisor, 10 is my quotient, and 7 is my remainder. So dividend equal to divisor into quotient plus remainder is a very true rule for any division problem that you take. I have introduced you guys to the terms over here. This is the dividend, this is the divisor, quotient, and the remainder. So for any number, if you are dividing it by any other number, you can always express it in this particular form. We are done with this particular part. Let us start with our main and basic important topic, which is the divisibility tests. So first we are going to have a look at the divisibility test of 2, which is very easy. You guys must be aware of the fact that any number is going to be divisible by 2 if it is going to be an even number. So for the number to be an even number, I can have any of these 5 digits, either 0, 2, 4, 6 or 8 at my units place. If any of these 5 digits is present at the unit place of my number is an even number. So I can have, for example, any number that will have any of the digits from 0 to 4, 6 or 8 in the units place. So I have some examples over here like 274, 632, 458. Only thing I need to check is the digit at the units place, and that will tell me if the number is going to be completely divisible by 2 or not. Next we have the divisibility test of 3. So even this is very easy. It says that the sum of the digits of the number should be divisible by 3. That means if you have been given any number, you have to take the sum of the individual digits of the number and check if that sum is actually divisible by 3. Let's take an example and try to understand with the help of an example. So the number I have taken over here is a very basic, a very simple number, a 3-digit number, that is 171. So if I need to check if the number is divisible by 3 or not, I'll take the sum of the individual digits. So the sum is going to be 1 plus 7 plus 1, which would be 9. Now 9 is actually divisible by 3. So since the sum of the digits is divisible by 3, I would say that my 171 is completely divisible by 3. Now not only a 3-digit number, you can have a number that is very large, like I have taken over here 155,8962. Make the sum of the individual digits 1 plus 5 plus 5 plus 8 plus 9 plus 6 plus 3 plus 2, which gives you the sum as 39. Now 39 is actually divisible by 3. So since my sum of the digits is divisible by 3, I can say my entire number over here is divisible by 3. So while I'm explaining, just note down the divisibility test so that you guys can have a note of that and remember it later on. So this is a simple divisibility test. The next one test that we have is the divisibility by 4. So the last 2 digits of the number should be divisible by 4. So you have any big number, may that be a 10-digit number or may that be a 2-digit number. The only thing that you have to check is the last two digits of the number. If the number that you're having has the last two digits which are actually divisible by 4, then your entire number is going to be divisible by 4. For example, I have a number over here 9076732, which is a 7-digit number. I only have to check the last two digits, which is 32. So the number formed by the last two digits is 32, and 32 is actually divisible by 4, completely divisible by 4. So I can say that my this 7-digit number is entirely divisible by 4. That is how simple it is. So till now we have covered divisibility test by 2, by 3, by 4. We will be revising everything, don't worry. Now the simplest of all is a divisibility test of 5. For divisibility test of 5, you should have either 0 or 5 at the units place. Very logical, right? So you can have any number that can have either 0 or 5 at the units place. You just need to check the units place. I have an example over here. I have taken the number 155, wherein I have 5 at the units place. So I can say that my entire number 155 is divisible by 5. The next test that we have is the divisibility by 6. Now from here starts the actual divisibility tests part. So for divisibility by 6, you have to check if the number is divisible by 2 and 3. Now I'll tell you why. If you have any number that can be expressed as a product of two prime numbers, now since it can be expressed as a product of two prime numbers, it is very obvious that the two prime numbers are going to be the factors of that particular number. So for example, I have a 6 over here which can be expressed as a product of two prime numbers 2 and 3. So while I'm checking the divisibility by 6, I have to check if the number is divisible by both the primes that I have taken. Now this case can be valid for any number which has its product as two prime numbers. The only thing that you have to do is check if the number is completely divisible by the two prime numbers, and that would satisfy your divisibility test. So over here we are talking about divisibility by 6 particularly. So I should check the divisibility by 2 and 3. So for divisibility by 2, it is very important that my number is an even number, so I can have any of the digits from 0 to 0, 2, 4, 6 or 8 at the units place. And for divisibility by 3, we have just discussed that we need to have the sum of the digits as a multiple of 3. So if both of these conditions are satisfied, only then my number is going to be divisible by 6. Let's see with the help of an example, you will understand better. So I have a number 678 over here. You can see I have 8 at the units place. That means my number is an even number, so it is divisible by 2. Also, I need to take the sum of the digits to check the divisibility by 3. So let's take the sum of the digits. It is going to be equal to 6 plus 7 plus 8, which comes out to be 21. Now 21 is completely divisible by 3, so I can say my number 678 is completely divisible by 3. So I have now proved that my number is divisible by 2 as well as by 3. So my number is entirely divisible by 6. So that is my divisibility. The next one I have is divisibility by 7. Now this is a little complicated of all. So let's see what it says. It says double the digits at the units place and subtract it from the rest of the number. Maybe you might have not understood the statement. Let's see it with the help of an example. It says first double the digits at the units place. So I have the number 203, which I have taken as an example. At units place I have the digit 3. So I am doubling the digit at the units place. It is going to be 3 into 2, that is going to be equal to 6. And subtract it from the rest of the number. So if I cut out 3 from this particular number, the number that remains is 20. Don't go for the literal meaning. Just understand what I mean to say. If I am cutting out 3 from here, I'll have 20 remaining. So before this I had the units place double as 6. What I'm going to do is subtract 20 and 6. So 20 minus 6 comes out to be 40. It is divisible by 7, so I can say my entire number is divisible by 7. So step 1, you need to double the digit at the units place. Step 2, you need to subtract the double of the units place digit from the rest of the number. And if the answer that you are getting is divisible by 7, then you can say the entire number is divisible by 7. One more example to just make the concept clear for you guys. I have 1771. My units place digit is 1. I'm going to double it first of all. So my doubling becomes 2. After doubling it becomes 2. If I cut out 1 from here, I have the remaining number as 177. So I'll subtract 2 from 177. So 177 minus 2 I get is 175. 175 is actually divisible by 7. So I can say that my 1771 is divisible by 7. So that is how you will find the divisibility by 7. Now you may feel that this is a very complicated divisibility test, but trust me guys, when you get 4 or 5 digit numbers in the exam, you cannot just keep on dividing it by 7, because that is not a fast method. You do not have a calculator that is actually apt for division. So what you can do is you can apply this 7 divisibility test very fast and come out with a. The next we have is divisibility test of 8. So for divisibility test of 8, I need to check the last 3 digits of my number, and these last 3 digits need to be divisible by 8. Now this is going to be useful only if you have a 3-digit number or where the number of digits of the number is going to be greater than 3. So I have over here a 6-digit number. It says the last 3 digits I need to check and check if they are divisible by 8. So I have the number 171640. You can see the last 3 digits are 640. My 640 is completely divisible by 8, so I can say my entire number 171640 is divisible by 8. That is how simple. The next I have is divisibility test by 9. So for it is just like the divisibility test of 3. For 3 you need to have the sum of the digits divisible by 3 completely. For 9 you need to have the sum of the digits of the number to be divisible by 9 completely. So let's take an example and try to understand. I have a number 171711. Let's find the sum of the digits. 1 plus 7 plus 1 plus 7 plus 1 plus 1. I've written it down over here. It comes out to be 18. Now 18 is something that is divisible by 9. So I can say my entire 6-digit number over here is divisible by 9. Now just try to understand how fast this method is, because you cannot just keep on dividing in the exam. You have a very time which is very precious. For such questions you should not take more than 1 minute to solve, and over here the divisibility tests are something that are going to prove very hard. The last and the very simple is divisibility test by 10. As obvious as the last unit place digit should be 0. So whenever the last digit of the number is 0, I can say my number is entirely divisible by 10. I have an example over here, 156890, last digit is 0, so I can say my number is divisible by 10. So that was all about the divisibility test. For divisibility by 2, you need to check if the number at the units place is either 0, 2, 4, 6 or 8. If it is an even number, it is going to be obviously divisible by 2. For divisibility by 3 and 9, you need to check if the sum of the digits of the number is completely divisible by either 3 or 9 respectively. If it is divisibility by 3, then check if the sum of the digits is completely divisible by 3. If it is 9, check if the sum of the digits is completely divisible by 9. For divisibility by 4, you need to check if the last 2 digits of the number are divisible by 4. For divisibility by 8, you need to check if the last 3 digits of the number are divisible by 8. For divisibility by 5, you need to check if the last units place digit is actually 5 or 0. If it is any one of 5 or 0, then the number is going to be divisible by 5. For divisibility by 10, you need to check if my last digit is a 0. If it is 0, then my number is obviously divisible by 10. Then for divisibility by 6, you need to check if the number is completely divisible by both 2 and 3. So it should be an even number and the sum of the digits should be divisible by 3. And the last one is divisibility by 7. So you need to first double the units place digit and then subtract it from the rest of the number and check if the remainder that you're getting is divisible by 7. If it is, then obviously the number is going to be divisible by 7. Just couple them out. Like 3 and 9 you have a similar formula. For 2 you have a similar formula as 4 and 8. For 6 you have a different formula. For 7 you have a different formula, and for 5 and 10 you can couple them together. So if you try to remember it that way, then you will divisibility tests. So that was it for this particular topic. Thank you so much for watching. Also don't forget to hit the subscribe button below and do like, comment and share my video if you like them. The second part of this video will be coming out very soon, wherein we will be discussing the divisibility tests from 11 to 20, which are a little difficult as compared to the ones that we discussed now. But let's go step by step. I will be discussing them in the next chapter. Don't forget to hit the subscribe button, do like, share and comment on my video, that you stay updated to all of the videos that we